Hello, good morning, and welcome to our final presentation. Did you know that in the north of Mexico in the month of June of this year, there was a huge lack of water? Also, the south of the country has the highest rate of flooding. Knowing this, our team decided to design a container of water which will be located in strategic points where the floods are coming in order to reduce them. Also, this container will be able to purify the water with thermal processes, and the clean water will be sent to regions that have no water.
First of all, for the state of the art, we need to consider that rainwater harvesting systems have become more and more popular for the importance of rainwater into turning back to fresh water so that humans can consume. Or also, the type of filters tend to be more of a physical type of filter made from gravel, car activated carbon, or sand, which can be easy things to accomplish, but they're a bit bulkier than what we were thinking about doing. Then we can consider scope of the work. The scope of the work, first and foremost, must consist from an environmental analysis because we do not want to harm the environment by trying to fix things for everybody because that will make a bigger problem in the long run. Then we need to consider how long it will take to create our machines and install them. Installing them should not be much of a problem as it would be pretty much just an ensemble and quick testing, which would take just about a week at the worst. Then we must consider around a month in which we will be taking the pieces, testing, and building the entire prototype so that we can give it to the different sources that require our
Here's a
product.
table of the positive and negative effects of our product. The risks that we are facing is that in the communities that we are going to work, there's not enough infrastructure. So first, we have to functionable infrastructure in order to start building the project. Another important risk that we are facing is the big companies who sell bottled water, because our product is giving to the people purified water and they can drink it without buying an extra filter. We are hitting the market of these companies. Lastly, the regulation of our containers could be a problem because we are trying to stop the floods in Mexico. Nevertheless, sometimes this water falls into the rivers and completes the water cycle. So in the future, we could leave rivers dry, and this will affect the environment. Some actions to avoid the negative effects showed in the table are in relation to metal gas pollution. While while we are purifying the water, all metals that came with it are going to be separated, and this could be used for the chemical industry. The space that the containers we will we will use could be optimized by creating a type of tank underground, reducing the space it requires on the surface. And also, our containers will have to be set up in geographical valleys and lower altitudes so as not to disturb the source of the rivers, which tend to be at much higher altitudes. The resources we will need are sand, activated carbon, plastic pipelines, pressure sensors, acidity sensors, hydraulic cylinders, and microprocessors. Also, we need people specialized in the installation of the containers and the maintenance or repair of the electronic components.
In order to make our project, we have to develop a task list and a milestone. The milestone is like the different phases that we need to complete our project. And we have phases like the problem to solve, the investigation, the planning of the project, the design, the cost of the materials, the construction of a prototype, the test of the same prototype, the construction of the final model, the search for a place to test the final model, and the start of building our final model in more cities and begin implementing in other places. And in these phases, we have the different activities that we need to complete, like the programming of the sensors, the define the objectives and problems that we may encounter define the stakeholders, search for different places to implement our product, test the different parts of our product, and solve any problem that presents in the test, and more activities. After we define the whole plan of activities, we have made a calendar and put a person in charge of that activity and define the approximate date to start and finish the activities, and also we could mark the progress of that activities. We have activities like design, make the sketch of the product, the separate part, the different parts in categories, and also choose section of the city to install our system when we start to construct our model in the city. And well, also we define some requirements that the customer might need, like the friendly interaction, a good degree of purification, that it doesn't need maintenance, or at least not in short periods of time. Also, we have to define some engineering requirements for the product to work as planned, like some durable sensors and actuators that resist all the water, the simple installation, and also maybe for some comfort, a mobile application that tells you when the water is totally purified.
Talking about the functions of our product, the main function is to store rainwater, helping the communities to reduce the floods that rain could make, because there are some without paved streets. Also, the trash on the streets covers the drains on the villages, and this generated a lot of floods. The second function is to purify the water contained. This will help the communities in order to drink clean water directly from the pipes, reducing the consumption of bottled water. As you can see in the function tree, our primary subfunction 1 is to contain water. Its secondary subfunction 1 is to be of a standard size, so it will be much easier to install. The primary subfunction 2 is to purify water at different degrees. Its secondary subfunction 1 is to direct water to different devices, so people can use it when they need it. Its tertiary subfunction 1 is to allow user manipulation. The secondary subfunction 2 of the primary subfunction 2 is to sense the purification degree. Its tertiary subfunction 1 is to manipulate the actuators, so the system can be modified if it's needed. And the tertiary subfunction 2 is to change the purification system. Our auxiliary subfunction 1 is to be remotely controlled. It's not the main goal, but it would be a very good plus. Our auxiliary subfunction 2 is to be powered with solar energy, so the contamination is the minimum as possible. And the auxiliary subfunction 3 is to be easy to install. The constraints of our product are the following. The needs of a large area, clear of foliage or buildings blocking the sky, large space of installation, big beginning cost, multiple drainage system for different chemical materials, environmental analysis assessment needed, need for maintenance, and solar power input is not always constant and variable.
The first thing that we came up with was the big issue that are droughts throughout our country. Then we started seeing that there's a bigger trend about people trying to make sure that lower income communities have water. And then we came into the idea of filtering water, which boiling it is a good way to make sure some of the problems get away. So if we were to able to turn it into vapor and back into water, in the separation, we could separate it from deadly chemicals from the acid rain.
So now it's my turn to explain about the concept sketchboard. So basically what we have here is a recopilation of all of our ideas. We gathered different ideas from different products that already exist, and we also improve added some new functions to this water container. So the basic idea was to have a cubic box, which will be of stainless steel. This box will have on the top part or the top side solar panels in order to be energized by itself or by solar energy. And well, we wanted also to improve this by making it automated. So we want to put some sensors on this part, so the machine could know where is the water level, and at what time to close this box. So after all the ideas that we presented on these drawings, finally we got to a final design made in CAD. This is our first prototype. It looks very simple, but it works. It is a um, functional prototype, a functional virtual prototype, which, well, I already said this is going to be stainless steel material. On the top, we wanted to put some solar panels, and well, all the electronic stuff and all the connections are not here, but possibly with more time we could make a functional prototype. So at this part, at this level, we wanted to put some sensors in order to know when to close the doors. We decided to do this cubic with a cubic form because well, this is going to catch the same amount of water at all time. So basically it has two steps: when it is closed and when it is open. The first step, well, is going to be, well, to capture the rain. So it will rain, and this container is going to storage all the water here. And then when it finally gets to a level, it's going to be, well, the the sensor's going to give a signal in order to close the doors and finally evaporate all the water that is inside and leaving the toxic substances at the bottom, and then we're going to filter that substances. And well, here's a short video of how it's going to open and close the mechanism. Finally, for the part of the FMEA, so following the function tree, we selected, well, three functions. The first one was to determine the temperature of the box, and the second one is that the box is powered by solar energy, and the third one is going to that the box can be controlled remotely. So based on that functions, we decided three sub functions that were related to that functions. And here are the potential failures of the sub functions that were in our functional tree. So these are related to the main functions, and this one, this column is related to the effect of the possible or the potential failure of the mode. Then, according to a scale of possible error, um, we classified this these possible failures, and also we uh, we included the potential causes of each subfunction. Then the current design controls, or what we have now, and with different scales we could determine the RPN, which this number was got by the multiplication of these three indicators. So it's basically a number that we can reach, or we know that what are we doing, and this will be helpful in order to know if what are we doing is correct or not correct. And finally, here we establish some recommended actions. For example, to install different buzzers or alarms that alert us about the possible failures of the sensors. And here are responsible well, the person in charge, and a estimated target completion date. So, for example, here Fabricio is in charge of installing the different buzzers, and here is the due date.
When we are designing a product, it is very important to know about the regulations that are related to it. A Mexican regulation is the NOM 127 SS A1 1994. This norm contains the permissible limits of different metals and the potabilization methods for every possible source of contamination. The most common pollutants in the rainwater are sulfates, nitrates, and chlorine compounds. The norm establishes that the permissible limits for these pollutants are 400, 10, and 250 micrograms per liter, respectively. An international regulation is the Directive UE 2020-2184. It's homologous to the previous Mexican norm, but in the European Union, telling the permissible limits of contaminants to guarantee a healthy and clean water. The limit for sulfates is 380, for nitrates 20, and 200 micrograms per liter for chlorine compounds.